Tripathi, and this is Avila Sarkar who is mentoring you. And recently, we have started a new chapter, that is fluid statistics, out of the complete subject that is named as fluid mechanics. We have uh, finished the theory part of fluid statistics, and now onwards we'll move to solve some numerical problems, including some conceptual problems also. Okay, so let me start with some easy problems to for your understanding, and later if I see uh, some important and unique problems or maybe a tougher problem also, I will discuss in this. So for sorry for that, I'm too much disturbed due to this uh, cold and cough, so I might not be able to speak very loud. That is creating some problem in my throat. I will be little bit uh, means in low pitch I will speak. So pardon me for that, but I think it will be sufficient to hear. It may not be so much lighter. So on that, so what I'm saying, we'll start with a very easy problem initially. Then after slowly I will build up the pace and I will move on to the some critical and very uh, very tough problem too. Okay. So the first problem on fluid statistic says the two thigh means a person, we are describing a person who is standing on two legs and the load is transferred to thigh. So two thigh bones, each of cross section. So if you can assume that thigh is of cylindrical shape and there is cross section uniform through the thigh, so that is the assumption, but in reality that is not like that. But anyhow, for the sake of the sum, we are assuming that the thigh are of uniform cross section. The bones each of cross section, each of cross section cross sections area 15 centimeter square, support the upper part of the person of mass 70 kg. The pressure sustained by this thigh sustained by these thigh thigh bones is how much? Okay. So this is a very straightforward. Means if I assume this is a person, the upper part of the body, and this is two legs. I am not keeping any gap in between the other. So these are two legs of cross section, something same cross section. Each support the upper part of the what is that the each of cross section means each is of area 15 centimeter square. This is in centimeter square, whereas the upper part of the person of mass 70 kg. This part, upper part is 70 kg. What is that? The mass. Okay. So now how much pressure is coming on to this thigh? I can assume that both of the thighs are sustaining same pressure. If I assume that, so that means 2P, that means P and P, the pressure is a scalar quantity. So 2P will be the total weight of the body divided by the area. This will be the case. Okay. So now how we will get the weight of the body? That is nothing but mass into the gravitational acceleration divided by the area. Now mass is given in 70 kg. That means it is in MKS unit or SI unit, you can say kg. And if I assume the G is how much? 9.81. This is meter per second square. Now area is given in centimeter square, 15 centimeter square. Now if these are in SI units, so this has to be transferred into the same unit. So area 1 centimeter to meter, we can move with how much? Centimeter to meter is divided by 100. So that has to be divided by 10 to the power 4. Now it will be converted into meter square. Fine. Now all these values are known. Now if we put the value, M is 70. Okay, G is 9.8. I'm not putting the units together, but anyhow that will come. This is area is 15 by 10 to the power 4. These are the units, and what are the units? This is kg, meter per second square, whole divided by meter square. Okay. Fine. So all things are there, so I can rub this part. Now the thing is numerical plus your unit. So this is 70 into 9.81 into 10 to the power 4 will go up, and this is 15. And whatever the unit kg, meter will be cancelled out. This is kg per meter into second square. Okay. Now pressure is a unit in SI unit. This is what is that? Kg means kg. This can be Newton per meter square. This can be Newton per meter square is the pressure unit. Now how come it is be Newton meter? Now if I multiply it with the meter here and I will put meter square here, so this all together kg meter per second square is nothing but what? Kg. That means kg meter is equal to the kg into means mass into acceleration. This is just something like that. Mass in kg, acceleration in meter per second square. So these all together is mass into, that is into your Newton. Mass into acceleration, this is unit of force, kg meter per second square. This is nothing but Newton. So this can be said to be Newton per meter square. Is converting now. Your term has to be to calculate the numeric. So now 15, 5, 3, 5, 1, 14, and if I multiply with this, 3 3s are 9, 3 2s are 3 7. Okay, so these all are cancelled. Only thing is that 3.27 into 14. So that means 98, 9, 14 to the 28 plus 9, 28 plus 9, that is equal to 37, 3, 42, 345, isn't it? So this is the case. Now if I bring one dot here, so this will be 4.578 into 10. So this 10 will be adjusted there with 10 to the power 4, that will become 10 to the power 5 Newton per meter square. Why I am doing that? Because this has a specific unit conversion. I can give in turn of this 10 to the power 5 Newton per meter square is equal to what? Newton per meter square, in other words we can say Pascal. So 10 to the power 5 Pascal is equal to what? 1 bar. So that is equal to, if I want to put it in respect of bar, I can put bar. Okay. So this is your answer. This much. My calculation is correct. Answer, okay. Let me check it once. 5 3s are 5 14. 3 3s are 9. 3 2s are 8. 3 1 8 7 14. 9 37 3. Yes, okay, sorry, yes. This is this much of bar. Okay, now this is equivalent to what? 2p. So if 2p is equal to 4.578 bar, what is your p? Half of this. So if I divide it to half, 2, this is equal to 2 2s are 1 7, 8 to 9 to the 18, 9 to the 18, this much. So this is this much of bar. Approximate answer is given 2.3. So this will be 2.33, or further approximation may come if somebody takes it at 10. And for approximation, this sometimes it is given as 10. So somebody if taken 10, so there are some more, because answer it has given is 2.33. So this is not matching because I have taken the exact figure. If you take 10, there is the answer probably this will come this one. Okay. So but anyhow, the process you understand. If you even take by declaring that g value I am taking 10, so that also be correct. So your answer, if it is even deviated or there is an option given, so nearest answer you can choose. Or if any choice is not given, if you take 10 and according to whatever answer is there, that will also be correct for you. Okay, so there is no harm in it. So moving to the next problem. Number 2. Number 2. Two liquids of densities rho and rho having their volume volumes in the ratio of 3:2 are mixed together. Find the density of the mixture. Okay, this is also very straightforward and easy, but anyhow, concept you have to know. When let's say two liquid, if it is not, if it is miscible, means they can mix each other. Two liquids mixed each other. So what are the things straightforward you can understand is that if two liquid in two beaker, if I that is there the volume V1 and V2, whatever with the volume, and if I poured it, means it is, let's say this 1 liter, this is of 2 liter, whatever liquid, and the liquids are miscible, that means they can mix each other as a homogeneous mixture, you can say. There is no nothing you can detect as a separate liquid by individually. This liquid can be detected as a separate liquid. There may be possibility the liquids are mixed and they form another liquid of some more other characteristic, but anyhow you cannot separate those liquids. So these are homogeneous mixture they will make. So if it is the case, the one thing that is possible, because this will carry the both the volumes, this is straightforward. Second thing is that the mass of this due to this volume and the mass of this due to this volume, if I club it together, that also to be same. So if it is the case, now mass of this mixture will be the mass of this, because I am not losing any mass, I cannot create mass. So if mass is completely transferred, there is no residue in that, if I assume that, so whatever mass is there, it is the cumulative mass of this, and volume also this, because in this process I am not I am not what is that, I am not compressing is with these liquids, whatever I will consider in, unless and until that said to be a compressible fluid, we have to assume these liquids are incompressible. So there is no other things happening, and it's not that liquids are separating with a line. So there may be possibilities that they compress each other, they are mixing each other. So the total volume of those mixture and total weight mass of this two mixture will not lose anything during mixing of this liquid. So you can say this is also intact, this is also intact. So now once you will get this and this, so what is your density formula? The density of any fluid is equal to the, we say, is mass by volume. This is the only thing. Here in this formula we are not saying the individual mass or the individual volume. We are talking about the mass available in a container and the volume it is occupies. Then this is the density. So in this case also we'll consider the same. So what is that? Mass of both the liquid together and the volume of this liquid together will be the case of their cumulative density cumulative. Okay, so this is the formula by which we will get now your consideration. So if it is the case, so the volume are 3:2. So we can assume that volume are 3V and 2V, and the density are given this. So cumulative density is equal to the total mass. So mass I will get volume into density, so 3V into its density plus this is the mass of the first liquid and the volume of the second liquid into its density will give you the mass of the, this is mass 1, this is mass 2, all divided with their volume. So that is volume of first liquid plus volume of second liquid. This is the formula. So now from this is 3 into 2, 6 0. So 6 plus 2. So that is 8 rho divided by 3 plus 2, 5V. So now V is not uh, taking part in this. So this is 8 by 5 rho will be the cumulative volume of this, cumulative density of this mixture. Okay, so that can be represented with the known parameter of the liquids. Okay, or the fluids, you can say. So we'll move on to the next problem, that is problem number 3. Now number 3. Number 3 says there is a glass tube with a liquid inside that is filled up to some length. Let's say this is 1 meter, that is inclined to the surface of 30 degree. Now this is height is given as h. P0 is the pressure, that means it is denoting atmospheric pressure, and this is P. The density of the liquid inside is fluid is rho. Now I have to find P. What is here? P. Nothing else is given. So this is this one. Now when we will derive the pressure formula, there the pressure at any point below is dependent on the atmospheric pressure, that is P0 plus H rho G. Now this has came from the initial, when I derived it, this depends on the P pressure is equal to P0 plus any additional force which is perpendicularly acting divided by the area of the cross section of the container. So this, from there we have arrived to this, isn't it? We have taken a beaker of fluid of height h. There, this is the atmospheric pressure here. Okay, and due to this fluid column, whatever pressure is coming, this is higher pressure than this one, and this is causing due to what? This fluid having weight W. So from there, P is equal to that force due to the what I have done, that P into the cross section, that force is acting completely, and that is divided into two parts, the atmospheric pressure into the cross section plus the weight of the water, weight of the fluid. This one, this is the force itself. So pressure into area, the atmospheric pressure into this. Now we have divided P all through by A, so we will get this one. Now this is the weight of the fluid inside, so this is always will act vertically down, and so that means this, when we have defined pressure, this is the vertical force divided by the area on which the force is acting. From there I will get the pressure. There also, during deriving this force, that is the weight will always act vertically down, so that we have taken as the vertical force. Here also the same thing, will not move with this, rather if I say this is nothing but the force perpendicular acting by the area of cross section of the fluid that is being considered to consider the force. Now if it is the basic one, if I go with now this force has to be vertical. Now this is not vertical force, and what is this force here? Here the perpendicular force is nothing but the weight, but weight is acting downward this way. So what is the force which is acting, this perpendicular force will be the component of this weight. One component I can assume this way. If this is 30, this is also to be 30, and the other component, that is this side, this is basically the W sine 30, which is equivalent to this perpendicular force acting on the liquid or the fluid column vertically on the surface. So this will be the responsible force to increase the pressure here. Not all, because this is acting, so the other force which is perpendicular, it will not act because force is a vector one. So the component which is acting in the same line, which will cause the pressure to be increased as per the definition. So this is P0 plus what is Ft is equal to W sine 30 by A. Now what is this? Now this can be treated as if this water column is vertical, okay, and this is containing the complete 1 meter of length of that same liquid, same fluid. So for 1 meter, what is your pressure here? If I say this is P1, so this is equal to W by A, weight of this fluid column, and that will be assisted by atmospheric pressure. But what is the difference of pressure in there? What is the difference of pressure? This will only cause due to the height of the liquid column or the fluid column. So that is the weight by the total weight of the fluid by the area. This will be the increment, and this P is nothing but the P minus the pressure here minus the atmospheric pressure. This is nothing but this one, P minus P0 will be the case. But if it is vertical, then this will be the unique case. If I make it vertical, this will give me the effect of total 1 meter. So what is that? This is the case. So now this is equal to W by A, actually sin theta. Now W by A is can be achieved by what is that? H, rho and G. Rho is there, H is equal to 1, rho into G. So this is equal to rho and G, W by A. So this is equal to rho in G into what is sin theta is equal to half. So whatever the value is given, rho and G are known. So this is half of this value. So this is your pressure. So pressure is nothing but the atmospheric pressure plus half into rho into G. This will be your answer here. Understood? Okay. Now move on to the next problem, that is problem number 4. At a depth of 500 meter, at a depth of 500 meter in an ocean, what is absolute pressure? What is absolute pressure given that the density of seawater is 1.03 into 10 to the power 3 kg per meters cube and G equal to 10 meter per second square. Okay, fine. At depth of 500 meter in an ocean, let's say we are talking about some ocean. Okay, this is ocean. Okay, and at a height of 500 meter down, what is the absolute pressure? So now below the sea level, we need to have absolute pressure. So when we are using this formula H rho g, there this is what we have learned. This is the absolute pressure, this is atmospheric pressure, and this is your gauge pressure. Okay, fine. So at the depth of 500 meter in an ocean, what is the absolute pressure you have to find, given that the density of the sea is this one. So in this formula, you know this is 500 meter, you know the density is 1.03 into 10 to the power 3 kg per meter cube, and g you know. Okay. So atmospheric pressure also you know. So if I put the value, atmospheric pressure is 1.01 into 10 to the power 5 Newton per meter square plus, if I put 500 here, into rho is 1.03 into 10 to the power 3, and your g is 10, we are assuming 10. So all these values are well positioned in this formula. Now the time is for, now here this is meter, this is kg per meter cube, and this is meter per second square. This all total will also give Newton per meter square. So units are same, only thing is the calculation will come 1.01 into 10 to the power 5 whereas this is 10 to the power 4, and if I take it is 5 2 this is 10 to the power 3 already. Now 500 1 0, so all this total together will turn into, I am just reducing the calculation, 10 to the power 5. So 50 into 1.03, that means 1.03 into 50, 5 3 15 5 0. So this one, so 51.5 plus 1.01 01 will add together 1525. So this will together, this will be 51.05 into 10 to the power 5. This all together, this is equal to Newton per meter square. Now after calculation, this will become 52.51 into 10 to the power 5 Newton per meter square. This you can say as bar. So now this is equal to 52.51 bar, or approximately the 1 atm, or this much of atmospheric pressure, you can say this much of atm, because atm and bar are all approximately same. Okay, so this here I am just ending my this session. In next session I will move on to the problem number 5 and further.